All right, class, welcome. So we're going to be doing 2.6 and 2.8 review today. So let's look at the first question. So what is the number of real solutions for this quadratic function? So if they're asking for the number of real solutions, remember that you're going to be using the discriminant here. Okay, so the formula for the discriminant, if you recall, is b squared minus 4ac. So remember that that's a, b, and c. So a is -1, b is 9, c is 7. So you're just going to plug it in. So we got 9 squared minus 4 times a times c. And then you're going to do the math here. So let's do it on this side. So we got 9 squared is 9 times 9, which is 81. You got -4 times -1, which is +4. +4 times 7, so this is +4. +4 times 7 is +28. And then you add these together, you get 109, which is greater than 0. Which means that if it's greater than 0, you got 2 solutions. You have 2 real roots or solutions. All right, so let's look at the next one. What is the number of real solutions for this guy? So A, B. Now this, you got to move this -3 needs to be moved over to the left side because you want to make one side equal to 0. So before we even do this, we should be moving the 3 over to the left side. And now we got 8x squared minus 11x plus 3 is equal to 0. Now we can identify, well, that's A, that's B, and that is C. So now we can use the formula. B squared minus 4AC equals, A is 8, so 8 squared minus, or I'm sorry, no, this should be B, which is -11. So -11 squared minus 4 times A, which is 8, times C, which is 3. So -11 squared is 121. 4 times 8 is 32. 32 times 3 is 96. So it's 121 minus 96. And that's going to give you a number that is greater than 0. If you were to subtract that, you would get 25, which is greater than 0. Therefore, we got 2 real roots. If it was equal to 0 here, then you would have 1 real root. If it was less than 0, you would have 0 real roots, or 2 complex roots. All right, so same thing for number 3. You want to make one side equal to 0. So let's move the 7x over by adding it to one side. And let's also subtract the 7 on both sides as well. That way, 7 minus 7 is 0, and -7x plus 7x is 0, and that goes away. So we got 0 on the one side. On the left side, we're just going to stack these guys, or we're just going to write these guys out next to each other. So we got x squared plus 7x minus 7. So we just wrote them next to each other. Now we know that A is 1, B is 7, C is -7. So we can plug into the formula. So we got B squared minus 4AC. 7 squared is 49. We got -4 times -7 is +28. Which is 67, which is greater than 0. So we got 2 real roots. And just so you guys know, let's just kind of summarize what we just did here. So to find the number of solutions, we use that formula. If it's greater than 0, we have 2 real roots. If it's equal to 0, well, that means we have 1 real root. And if it's less than 0, like a negative number, you have 0 real or 2 complex. Okay, so that's just to summarize what we did, what you would do in that lesson, depending on, your cases. All right, so let's look at number 4. During a manufacturing process, a metal part in a machine is exposed to varying temperature conditions. The manufacturer of the machine recommends that the temperature of the machine remain below 132 degrees Fahrenheit. The temperature T in degrees Fahrenheit, X minutes after the machine is put into operation, is modeled by that quadratic function. Will the temperature of the part ever reach or exceed 132 degrees Fahrenheit? Use the discriminant to decide. Okay, so this is another discriminant question. So it's saying, will the temperature, or T, ever be equal to 132? So that's what we're going to plug in for T, the temperature. So we got 132 is equal to all of this. Okay, so we're going to write that out. So let's write that out over here. This is for number 4. So the temperature T is equal to 005 squared x squared plus 0.45 x plus 125. All right, so we want to see, are we going to have a solution here? In order to do that, we're going to do exactly what we did in problems 1 to 3 earlier. We're going to set one side equal to 0, so I'm going to move the 132 over by subtracting it. Whatever you do on one side, you do to the other side. So that cancels. Now we have 0 there. Bring down everything else. You're going to have to subtract this down. So this is going to be -7. All right, now we're going to do the discriminant. Remember, b squared minus 4ac. So this is a, b, c. So we got 0.45 squared minus 4 times a times c. And then we're going to see the answer. So we're going to plug this into the calculator and see what we got. So 0.45 squared So if you plug this in, you're going to get 0.0625, which is greater than 0. All right, if it's greater than 0, that means that you have a solution, right? So to answer the question, since the discriminant is greater than 0, then we can go ahead and answer the question. It's asking, will the temperature ever reach or exceed 132? So since the discriminant is greater than 0, the temperature will reach or exceed 132 degrees Fahrenheit. All right, so now let's look at number 5. So we want to solve this using the quadratic formula. Let's write that problem over here. All right, so that's number 5. So we got to write down the quadratic formula first. So let's write it down over here. So the quadratic formula from your notes is negative b plus or minus square root b squared minus 4ac all over 2a. So we're going to plug into that. So we got x is equal to, remember that this is a, which is -1, b, which is 6, and c, which is -5. So we got -6, negative b, plus or minus square root b squared minus 4 times a, which is negative 1, times c, which is negative 5, all over 2 times a, which is negative 1. And the rest is just calculating this. So then you're going to calculate this inside the radical first. So 6 squared is 36. 4 times, so we got negative 4 times negative 1 is positive 4. And then positive 4 times negative 5 is negative 20. And then 2 times negative 1 is negative 2. So we got here, we got negative 6 plus or minus square root of 16 over negative 2. Square root of 16 is 4. So we got ourselves two answers that we got to do. We got to do negative 6 plus 4 over negative 2. And then we have to do negative 6 minus 4 over negative 2. So negative 6 plus 4 is negative 2. Divide that by negative 2, you get 1. Negative 6 minus 4 is negative 10. Divide that by negative 2, you get 5. So it looks like x equals 1 and x equals 5. All right, so we're going to go ahead and do number 6 down here. All right, we're going to do the same thing. So we got x is equal to, we got a, b, and c. So we got negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. Two negatives here make a positive, so we got a positive 5 plus or minus. This is going to give us 25. Negative 4 times negative 2 is positive 8. Positive 8 times 5 is positive 40. 2 times negative 2 is negative 4. All right, so it looks like we have 5 plus or minus square root of 25 plus 40 is 65. Divide that by negative 4. So we got to break down the 65 to see if anything goes into it that we could take the square root of. So in this case, 65, we got 5 goes into 65 13 times. And that's it, folks. There's nothing else that can break this down. There are no pairs here. So since there are no pairs of numbers, we just got 1, 5, and 1, 13. We can leave this square root alone. We don't have to do anything to it. Okay. So we leave it as. You can leave it as this, but you want to. Let's go ahead and split this into two fractions. Split it into 5 over negative 4, and then square root of 65 over negative 4. So we got 5 over negative 4, which is just going to be negative 5/4. So you could bring the negative in front. Plus or minus square root of 65 over 4. And it doesn't matter that you have the negative sign there because it goes into the plus or minus sign anyways. So you can leave it like this, right? All right, so let's look at number 7. All right, this one, number 7, looks a little different because you see that the one side is not equal to 0. This negative 4 needs to be moved over to the other side. So we need to move that over by adding it to both sides before we even use the quadratic formula. So we got negative 4x squared plus x plus 4 is equal to 0. Now we can use the quadratic formula for that. Let's do that over here. All right, I just want to double check, make sure that's good. Okay. All right, so let's use the formula. Same way. That's a, b is 1, c is 4. So we got negative 1 plus or minus square root 1 squared minus 4 times a times c over 2 times a. So we have negative 1 plus or minus 1 squared is 1. Negative 4 times negative 4 is positive 16. 16 times 4 is 64. So this will be positive 64 over negative 8. So it looks like we got negative 1 plus or minus square root of 65 over negative 8. And kind of like this one, we can split it into the two numbers, 1 over 8, and then square root of 65 over 8. All right, so those are our two answers. All right, let's look at number 11. Carlos chips a golf ball up a hill using his golf club. The path of the ball is modeled by the function y equals negative 1/2 x squared plus 20x, where x is the ball's horizontal distance from Carlos in feet, and y is the ball's height in feet. The hill is modeled by the line y equals 1/4 x. How far does the golf ball travel horizontally before it hits the ground? All right, so we have basically a system of equations, right? So we have y equals negative 1/2 x squared plus 20x. We have y equals 1/4 x. And we want to solve this guy. So we know that y is equal to 1/4 x. So we know that this is y, but this is also y. So we can set those two equal to each other. So we could set that equal to that. And then we could solve that like normal. Okay, so this is quadratic. You want to make one side equal to 0. So you're going to move this 1/4 over to the one side by subtracting it. All right, so we have negative 1/2 x squared. Now you could choose to do this as a decimal. I'm going to keep mine as a fraction, all right? So I'm going to keep mine as 20 minus 1/4, and I'm going to combine those two fractions together. So we need a common denominator here. So I need to times this by 4, times this by 4, so that we have a common denominator of 4. So this will be 80 over 4. So 20 will become 80 over 4 minus 1 over 4. So this is going to give me 79 over 4. Is equal to 0, and then there's an x there, is equal to 0. All right, if you want to leave it as a decimal, that's okay too. It should work out. If you were to do it as a decimal, then you would have negative 0.5 x squared plus 19.75 x equals 0. Either way, you're going to get the same answer. So let's go ahead and solve for x. Now, since you know that you have an x in common, you can actually factor that x out. So let's pull the x out, like that. So if I pull the x out, I have negative 1/2, and this guy has one x left over because I pulled out the x. So it only has one x now. The 79 over 4 has no more x's attached to it since I pulled it out. And then you're going to use the zero product property. The zero product property is when you have two things multiplying each other, you want to set each of them equal to 0. So this is equal to 0, and this is equal to 0. So then we can solve, this is obviously just going to be 0. This one you have to solve, so we're going to solve it by moving the 79 over 4 to the right side. And then we're going to multiply both sides by negative 2. And that will actually get rid of the negative 2 down there. So then you got to multiply 79 and 2 together. 79 times 2 is 158. and then there's an invisible 1 there, so 4 times 1 is 4. All right, and that's our final answer, 158 over 4 feet. All right. Number 12. So use graphing to find the number of solutions. So this time we just want to focus on the graphing part. We don't want to solve it, just graph it. So in order to graph this guy, I need to find the vertex. Okay, so let's find the vertex first. Remember, to find the vertex, we need to use the formula, negative b over 2a. That gives us the x-coordinate of the vertex, right? So let's find out a, b, and c. So a is 1. So let's plug it into the formula. B is 7. A is 1. So if you plug it in here, well, okay, so negative 7 over 2, that's about negative 3.5. That's negative 3.5. So our vertex is at the negative side. So if I were to draw this, it's just a rough sketch. It's nothing too detailed here. So I know that the vertex is somewhere, around in this area, right? I need to figure out what the y-coordinate is, though. So let's find out what the y-coordinate is. This is only the x-coordinate. So if I want to figure out the y-coordinate, I'm going to plug this into the original. All right, so if I do that, y equals negative 7 over 2 squared plus 7 times negative 7 over 2 plus 7. All right, and I'm just going to get a decimal out of that just because I have a lot of stuff going on as far as squaring is concerned. All right, so if you do that, you get negative 5 1/4, so just negative 5.25. And then if I convert x to a decimal, that'd be negative 3.5. All right, so the point is that the vertex is somewhere around here. Okay, we're not going to get a very specific graph, just a decent graph will do. So we know that a is positive, right? So this a is positive. Positive graph means it goes up. So we know it's going to go up somehow. And now let's focus on graphing this guy. Now this guy is of the form mx plus b, right? Remember the slope-intercept form? So you're going to graph 2 first. And I'm going to do this in a different color. So that's my 2 right there. And then my slope is m, which is 1. So that means I'm going to go, so that my slope is 1, and 1 is the same thing as 1 over 1. And remember that this is rise over run. So that means I'm going to go up 1, and then over 1. Up 1, over 1. Then I could draw my line. Okay, so like I said, just a basic sketch. You don't want to be too detailed because all you're looking for is the solutions. So you have a solution, oops, that's pretty big. You have a solution here and a solution there. So you got 2 solutions where it crosses. So our final answer, to find the number of solutions, we have 2 solutions. All right, let's do the same thing for number 13. So let's find the vertex for number 13. So we're going to use the formula negative b over 2a. This will give us the x-coordinate. So a is negative 1, b is negative 4, c is 1. So we got negative 4 over 2 times a. 2 negatives make a positive, and then we get negative 2. 4 divided by negative 2 is negative 2. So we know that the x-coordinate is negative 2. Plug it into the original to get y. So y equals negative 2 squared minus 4 times negative 2 plus 1. So negative 2 squared is 4. Negative 4 times negative 2 is positive 8, and then plus 1. So 4 plus 8 is 12, so we get 13 here. So my coordinates for my parabola are -2 and 13. So somewhere around here. Now, the parabola is going down because a is negative. Since a is negative, the parabola is going down. All right. And then for our graph, so this is mx plus b. So my slope, my y-intercept is -3. So let's do that first. So we're going to plot that down here, different color. And then our slope is -1. So that means that slope is -1, which is the same thing as -1 over 1. So remember, this is rise over run. So you're going to go down 1 over 1. So down 1. Let me adjust just real quick. And then over 1. All right, so then we can do our graph. Like I said, it doesn't have to be a very detailed graph. You can clearly tell that if you extend this parabola this way and this way, it's going to cross at 2 spots. So again, we have 2 real solutions. All right. And that's all there is to it. So you just have to figure out the number of solutions. You don't have to like figure out exactly what solutions they are. And that's it, guys. Those are the skills for 2.6 and 2.8. Quadratic formula, maybe a word problem in there, and using discriminant and graphing. All right, hope this helped, guys. Good luck, and I'll see you in the next video.